Hello! In this video, we're going to look at page S01 of our Namgyal prints. There's a lot of information here. Some of this is review, and some of it is stuff that we've already looked at. First off, we'll see cross sections, and notice that's cross section 3. We can find that cross section on page S06. Something new to us, this FFE, we didn't do this on our foundation plans, but that's finished floor elevation, and it gives us 1179.5. That's feet above sea level in this case. You'll notice that T equals 5 inches. You should know what that is. That's the thickness of the slab if you forgot. So the thickness of the slab is 5 inches. We'll also notice we have WWF, 6x6, W2x W2 and sheets. We haven't talked about sheets. But basically our welded wire fabric can come in two forms, sheets or rolls. I prefer sheets because you lay them out, tie them together, and off you go. Rolls, you have to straighten them out, bend them out, and get them right. It's a pain in the butt. But this 6x6, remember, is our wire spacing. That's the grid that's here, the waffle pattern. And the W2x W2 is the diameter of the wire in this case. We will also notice on this drawing, we have F2. We'll see an F1 down here, another F1 here. We're going to look at those a little later. That's going to be on a different drawing for us, and we're going to take a look at that in a minute, but that's going to be has to do with a footer kind of stuff that's going on. You'll notice there's section 13, 14, 13, 14, and so forth through here. Shows that we're the same throughout, but that's going to have to do with a haunch that we're going to look at in a little bit, and that's the cross section on S06. We're also going to look at this F7. So see there's F7 here, there's an F7 there, F7 here, and an F7 here. And that goes along with that page S07, that detail A on page S07 of this pilaster that's here. And this pilaster is a thickening of the wall. You can see how that sticks out. That thickening of the wall in this case is giving this beam that sits here a directional seat. And you'll see that there's a structural piece here of how big that beam is, and it also gives us our lally column that's going to sit there, and that lally column, remember, is going to sit on top of that footer. And that should look familiar to you because we just finished those in our foundation plans. Something on this page that we haven't looked at is this header schedule. And the header schedule refers to the headers that are here throughout this building. Remember, this is the first floor, and over here was our foundation. So this is referring to these headers. You notice there's H2, 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 H4, H2, and so forth. And there's going to be other headers throughout this building structure and other buildings on this site that are going to refer back to this header schedule. What a header schedule is, it gives us a mark. So H1, H2, H3, H4, it's going to refer to these. It's going to give us the size. In this case, this is 3 of them at 9 1/4 LVL. What that means, it's a 9 1/4 inch tall header. Well, what is a header? Well, I made this quick sketch that shows what a header is. If this were the doorway, so this is where the door is going to sit, this is where we get the ability to walk through a wall. This doorway has to be held up because there's stuff on top pushing down on our wall. Because there's stuff pushing down on the wall, we need a beam, in this case called a header, and that header supports the weight of the building above the door and transmits that weight to things called jack studs. In this case, there are 2 jack studs. The jack studs go from the sill all the way up to the header and support the weight of the building above that. If I pull this out of the way, you'll notice that this says 2 jack studs each end, and that's what this sketch is showing. It's showing 2 jack studs on each end. Outside the jack stud right here, that's called a common stud, and a common stud goes from the sill up to the double top plate. In between the header and the double top plate, we will find something called a cripple. And that cripple, again, is giving us that structural stability of our building. So anything that's placed here, the weight will be transmitted down through that double top plate, down through the cripple, into the header, and then out to those jack studs. So that is what all of this is referring to. In addition to that, on this first floor plan, this drawing right here, we'll find these lines that are dashed. They're a double dashed line, and it has some naming conventions going on here. They're 11 7/8, and that's the height of a TJI. And remember, we've looked at those in class. They're the little wooden I-beams called a truss, joist, I-joist. That 210 refers to the size specification of that truss joist I joist, and you can look in the PDF file in Schoology to find out that information. Also, the at 16 inches on center, that's OC. That means there's a floor joist going this way every 16 inches all the way across this building till a certain point where they change. You can see that this has changed because this first 8 feet gets what's called blocking. After that, there's no blocking, and then the blocking starts again. So what the heck is blocking? Made another sketch, and I'm going to show just a common floor joist. These are common floor joists, and they're running parallel to one another, just like they are running parallel here along this building. As they run parallel, if I get a lateral load pushing this way, because there's such a span here, these can actually fold over. So think of beams like this, and they would fall over like dominoes. And those dominoes, that's not a strong way to build things. So we put in blocking, our piece of wood that spans between one floor joist to the next, and it squares it off like a block. What that does is prevent that domino effect from happening. We're going to now jump to the footer schedule on S06, and we're also going to find all of these sections on S06. So let's make that transfer. So here we are on page S06. Let's slide up and show you that. S06 is here. I'm going to jump right up to the top of our drawing and see that there's an individual footing schedule. Remember back at the beginning of the video, I showed you F1, F2, F3, F4, and so forth. That refers to the footers for those lally columns, and it gives us the length, the width, the thickness, the BOF. I'm like, what the heck's a BOF? Well, if we look down here in our key, we'll find that's bottom of footing. And remember, a set of drawings will have all the information we need to interpret them, as long as we know where to read it or how to read it and where to find it. So we're just going to look down here and see that's bottom of footing. It shows us the bottom of the footer is 1177 above sea level. It also gives us the reinforcing wires at the bottom of that. And you can see here, here's a detail of that footer. Here's our lally footer. You can see that the column is working its way up through. There's that 5-inch pipe. That's going to be our lally column. You'll notice that also has a base plate detail. And we can look around here and find the base plate detail drawing if you wish. Basically, it's going to be right here, and it shows us how big that base plate is, all the holes, and how it's put together, and how it's anchored to that footer. Also shows us that we have what our fill material is. It shows us our floor. It shows us a lot of information. Remember, this just shows us what that individual footing schedule is, how big they are. In addition to that, next to that chart is another chart, the ICF wall footing schedule. This is insulated concrete form wall footing schedule, and that's going to refer to all those walls that float around outside that building, hold up our whole building. And insulated concrete forms are a styrofoam form that look and act a lot like Legos, where we can just stack them together, pour them full of concrete. They're already insulated, and we do not have to strip that form when we're done. So jumping back to S01, we'll see this typical detail S07, and that's that A S07. So I'm going to jump to page S07. So here we are on S07, and on S07, we're going to look at detail A. It's in the upper left corner, and this gives us a whole bunch of information as well. But this is the pilaster detail, and this is where it shows that wall's an extra thickness. It's 1 foot thick, as opposed to here, the concrete's only 6 inches, which with the ICF would probably make that somewhere in the neighborhood of 8 or 9. This is going to be a full foot thick of concrete, and that's going to support that beam that we looked at earlier on page S01, as well as it shows us our TJI, that's that little I-beam floor joist, and also shows us our blocking. Here we are back on S01 again. I mentioned earlier that we're going to take a look at this sections 13 and 14, and they're really important to understand how that works. Let's jump to page S06. Here we're on X06. We're going to down here at the bottom middle of the page, we'll find section 2, 13, and 14. So there's different pages that we're going to find these sections on, but they're all the same section. And what it's showing is there's a wall sitting on top of the floor. And a lot of times when we have a weight-bearing wall sitting on top of the floor, we need to add extra structure underneath the floor because our 5-inch thickness of our floor is not enough to withstand the force. So what's happening here is we put this depression in the ground. And that depression is called a haunch. That haunch has some specifications. That haunch has to be 1 foot 6 inches wide. It's going to taper up somewhere in the neighborhood of 9 to 7 inches up on a vertical elevation, so 9 to 7 inches this way, 1 foot 6 this way. And that haunch gives additional structure. That extra 9 to 7 inches gives us additional structure for that weight-bearing wall to sit on, so that it doesn't push its way through the concrete and make a big crack here. In addition to that, you're going to find a bunch of information about the rebar in here. Remember, the number 4 or the number 5 refer to the number of eighths of diameter that rebar is. This is 5/8, that's half an inch. In addition, you can see right here, just like we have on our floors, we've put in welded wire fabric. And again, the spacing of that 6 inches by 6 inches, and the wire diameters 2 and 2. That's the gauge of wire. Remember, I showed you that on a gauge in class. It also shows us that we have the studs at 16 inches on center. And it also gives us our sill plate, just so like we did the detail in our buildings. We have a sill plate, we also have a sill bolt, and all that information is found here.